Whitehead articulates what has come to be called Mereotopology. Mereology is the study of holes and parts, and he wants to understand the relations among wholes and parts in the continuum of possibility. Topology is the study of these relations. Topos meaning place, right? It offers, I think, a more concrete approach than what we usually think of as geometry. Topology is non-metrical, so you don't need rulers and coordinates or fixed scales. And so the point here is that aside from a select group of human beings, most organisms don't make decisions using meter sticks. They're not going out measuring the world. Cells, as they engage in embryological development, are not calculating one another's coordinates. I think the engineering mindset that imagines DNA as a set of instructions for computing where each cell needs to be at each moment mistakes an algorithmic blueprint for what is really more like a felt field. So I think a topological lens helps us see this more accurately, more sensitively. So we begin with the whole when we're talking about life and organisms, not with the parts. Let's begin as, Mike Levin will often say, we all begin as physics and chemistry, as a fertilized embryo, and then out of the process of development you get Descartes or any human being. So we begin as one cell. That cell divides. You begin with the whole and then get the parts, in other words. So development is not an accumulation of discrete parts that finally produces an organism. It is a whole that differentiates into parts. The whole precedes the parts. So in mereotopological terms, I think we can see how boundaries are not rigid seams, but dynamic neighborhoods that thicken and thin as the organism negotiates its own becoming. Parts are not molecular parts, say, they're not little machines that get bolted together. They're regions of a living gradient, and they're transiently stabilized by ongoing relations within the whole. And again, the whole precedes the parts here, right? That's what's crucial. And I think Levin's account and his lab's account of bioelectric fields helps us operationalize this into an empirical research program. This isn't just a speculative idea about wholeness. So if we approach development with an overly mechanistic or engineering mindset, I think we're always going to try to assemble the whole from pre-made components. We're going to be assuming a geometric picture that presumes we can measure everything in advance and assign each piece its coordinate. What I'm calling a topological approach here, speaking loosely, is more organic. It's about feeling one's place in a gradient, just as each cell feels the shape of the bioelectric field around it. And gradients here are evaluative fields. They do not merely constrain, they invite, they goad. And following Whitehead, we can say that the cell prehends its neighborhood. It feels relevant features of the past environment, relevant relative to the field of adjacent possibilities that halo it. And then it decides. Field effects like bioelectric potentials, morphogen gradients, tissue level tensions are not organizational afterthoughts. They're the medium of agency at the scale where the organism's aims become operative. None of this denies the role of molecular interactions, genes, proteins, signaling cascades, and so on, but it places them within an organismic topology. To treat DNA as if it calculated coordinates is to mistake a syntax for semantics and a semantics for a lived pragmatics. The organism is not passively implemented by code. It's actively metabolizing relevant information. So the causal story is not a one-way push for molecules upward. It's a many-leveled resonance in which the whole converses, the whole conserves itself by continually differentiating.